Bermudian triangle's about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grafing out the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
Alright, what's up, everybody? Let me fix that. Alright, one sec. There we go, that's fixed. Ooh, alright, it's Sunday. This is a unique stream. We don't usually do streams on the weekend, but I have a final exam that I'm giving to my students tomorrow at UCLA, and I told them I'd host a little bonus stream for them for Sunday if they wanted to ask any last minute questions. I know some professors do like review sessions like on campus during the weekend, but I don't have a very big office.
Surprise, motherfucker!
So I can't really fit everyone. If everyone showed up, my whole office would be slammed. So I'm doing it online here for now. Anyways, let's see. Hopefully chat's... You guys tell me in chat. Does chat work? It should, I hope. Chat. That's what they're always saying. Hey, chat. I see we got 14 viewers on at least. Priyana says yes. Oh, hi, Priyana. Good to see you. Nice. Yeah, so my format for this, I mean, this is, so I don't know if you've ever watched any of my live streams before, but what I generally do is I just have students ask questions. You can either like submit screenshots of specific questions that you have, but given it's our UCLA physics class, I already know all the questions. Like, if you just give me like a question number or something, I'll just go through something. You can say like, oh, the practice final this, or the whatever this. When is the lab grade going in? That's a good question. I actually have no clue. Lab does not tell us shit. I'll tell you straight up. Like the lab. Well, I did get one email from them. Here, let me see. I got a cute little email from the lab people. Let me see. Yeah, this is all I got from lab. Lab was like, hi, my name's Enzo, and we have a survey that we would like the students to fill out. They sent this to me yesterday on Saturday. I'm like, you do realize, bro, that the class like ends. The class is already over, first off. Like, I don't actually see the students besides the final. But they... Oh, and lo and behold... Oh, wait, yeah. I was like, wait a minute. Does their link even work? Okay, here we go. The Learning... Dude, what? The Learning Assistance Alliance? That's interesting. I didn't know they had like an alliance. Okay. But, okay. I guess they have a feedback form they want you to fill out, but I don't really expect any of you guys to fill this out. It's okay. I mean, I'll send an announcement out just for like good measure, but I'm not sure they're actually gonna get any much responses. Anyways, yes, I'm glad you guys found the stream. At least some of you guys. I know it's sometimes weird with like links and stuff. So it is on a vertical format for YouTube. If you want to view it in like horizontal, I also stream that on Twitch. If you're on your phone, the vertical makes more sense. If you're on like a desktop or something, the horizontal would make more sense. And you can find that if you just go to like actualdiscord.com/submit, or here. This is the I'll paste the Twitch stream. This is the Twitch stream that's horizontal. Yo, what's up, Darren? Yeah. There you go. That's it. If you want to view it horizontally. You said it wouldn't affect our grade. Oh, no. The lab grade will 100% affect your grade. It's because it's 15% of your class, right? It's 15% of your total grade. So, but that should be an easy 100, I would hope. A lab is usually a joke, right? Like, you don't really have to do much for lab. So, yeah, some students have, like, come into the office and been like, hey, I'm really worried about my grade and stuff. And I tell them, hey, you got an easy 15%, which is 1.5 midterms worth. That should be just 100 going in. I just don't know when they put that in. I gave them permission, I think, on Canvas to edit grades, but given how, like, lab, like, I don't know, very rarely has their shit together, I don't know when that's going to happen. Hi, I'm new. What's this channel about? So we're a nonprofit that helps kids with math and science. We do free tutoring and whatnot. But today's stream is specifically for my students at UCLA who are taking a final exam in physics tomorrow. So I'm helping them out with stuff. One sec. Let me go through all the chat. You guys got a lot of stuff in the chat. Let me go through. One sec. Ugh. Okay. Do you mind sharing which harder practice questions from Kudo are on final? I can't just tell you. What? No. I can't say which ones. I would say that, wait, let me go look at the Kudo stuff real quick. y'all being sneaky, thinking, like, can you just tell us what's on the test, please? Let's see. Do you mind adding the lab portion for us to play with the grade? I don't know what that means. What do you mean play with the grade? Can you guys change your grades? I don't think you can, right? No, that would make no sense. Like, what? He said, one day you leave this world behind, so live a life you will remember. I love the Avicii quote. Yeah, nice. Okay, one sec. What is it? This is it? Harder practice questions? Okay, let's see. Let me see which ones are on here. Okay. All right. I think 3 of those. Three in some form. Again, they're not exact. And don't, like, hold my, hands tied and be like, Dr. G said that it was exactly 3.5 questions, so you didn't do it. You lied to me. Like the add the assignment for us to enter what we... How do you do that? I don't know how to do that. Good. Someone's got an actual question. Can we go over MCQ 14, the practice final? It doesn't make much sense. Yeah, let's do it. Let's do it. Anyways, okay, cool. Let's start off the stream. I'll announce everyone else. Okay, here we go. All right, welcome everyone. Office hours. My name is Dr. Gold. This is Actual Education, a stream that helps you with math, homework, science, homework. Nice. All sorts of stuff. Today, we are going over specifically physics. So I usually take questions from everyone, but today, only physics. So, let's do some physics. I need to go find... One sec, I need to go find the practice final. Modules. Where are you? Practice final. Yes, there you go. Okay. And then it was number 14. Was this the one? Someone was telling me that, like, the multiple choice answers are off or something. Or, like, maybe, I don't know. Here, let's pull it in. All right, Sancheesy. So here we go. It says, heavy block of mass 10 kilograms is supported by 3 ropes as shown. Find the values of tension in the ropes labeled T1 and T2. Yes. Y'all remind me after we finish this one. All right. So first thing I do when I see something like this is I'm going to draw a force diagram for what's happening on T3. Okay. So T3 has the force of gravity pulling down. Okay. Which that's going to be equal to mg. Or sorry, block. Let's just call this block. Whatever. Block has Fg pulling down. And then it has T3 pulling up. Okay. Now, if the block is staying still and not falling or anything, right? That means that the sum of forces here, which equals the mass times acceleration, this has to be 0. So that means T3 pointing up minus mg pointing down must be equal to 0, or that T3 must be equal to mg. That's just looking at sum of forces of the block. And that tells me what T3 is, pulling up on this. Now, what I like to do is kind of imagine some mass here. This is like a juncture point is what this is. That doesn't weigh anything, but it has a bunch of forces acting on it. And I know that this juncture must be, you know, staying still. It can't be moving because we say everything is... We assume everything's at equilibrium, like nothing's moving. In that case, this is going to have T1 pulling this way. It's going to have T2 pulling this way. And this is going to feel T3 pulling it down, okay? Now, what we learn, right, is in a rope, tension at either side is the same, but just points in opposite directions. So here, tension on the rope pulls this way. Here, tension on the rope pulls this way, but it's the same T3. And that T3 was the same thing as mg, because that's what's the tension. That's the tension needed to keep the block from like falling all the way down. That'd be bad. Okay, so first thing I like to do when doing conservation of energy, why isn't work negative like calculating net work? It's because energy is equal to the negative work done, Darren. I can get into that, but yeah, that's where it comes from. Okay, so T2 is gonna have components. Actually, let's come up with different colors for this. Let me say this. It has this amount, which I'm gonna call this like T2y, and it's gonna have this amount, which I'm gonna call T2x. Okay. Now, if we look at sum of forces in the x direction for our little block here, right? I have T2x pulling to the right, and then I have T1 pulling to the left, so that's minus T1. And this all has to equal 0, because I need the mass times acceleration equal to 0. If we look at the sum of the forces in the y direction, okay, I have T2y pulling up, and I have T3 pulling down. Yes, good, Don. Yeah, you're right about that. Yeah, we're going to get into that, right? So, and this is equal to 0. Cool. So, I have a bunch of variables here I don't know, right? I don't know T1. I do know T3, right? T3 is the same thing as just mg. So, actually, that can kind of, like, help us out, right? We know this is equal to mg. But the issue here is that I have 3 unknowns, like T2x, T1, and T2y, but I only have 2 equations. And in math, you can't do that. You need at least as many equations as you have numbers of things that are missing. So what I want to do is I want to rewrite T2x and T2y in terms of like one variable. And what I can do is write that in terms of T2. So if this is, and here, let me draw this. Let me do a different picture here. Okay. If this is T2, okay, and then we say that this component here is T2y, and then this component here is T2x, then this angle here, right, that's equal to the 60 degrees. And so T2y, looking at my triangle here, this is the opposite side to this angle. So I can say, okay, cool. The sine of 60 degrees is equal to the opposite over the hypotenuse, which is going to be this. This is the opposite, because this side is opposite to this angle. T2y. Over the hypotenuse, which is just equal to T2. And so that tells me that T2 sine of 60 degrees is equal to T2y. What's up, Fem? Yeah, we do have the National Guard that came in today. LA's fucking wild today, man. Yeah. Luckily, I'm in a good part of LA, Fembox. It's okay. Yeah. That's downtown. That's really getting wrecked. I live on the west side, so it's okay. But yeah, crazy times. Anyways, yeah, so T2y is the sine. Then T2x is going to be the cosine. anytime you figure out that like, oh, sine or cosine is one of the directions, the other one is always the opposite. Just normal military silencing protesters. Yeah. 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 To be honest, if you want like my honest opinion over it, it's just bait. Like, Trump's just trying to get people to overreact, and then he can declare martial law and do whatever he wants in California, which would be unfortunate. Protesting is fine. The issue is that protesting is turning into like throwing things, and then the police get involved. Well, actually, LAPD is not getting involved because they don't agree with it anyways, or the mayor doesn't agree with it. But the issue is that then ICE has like justification to like start shooting back. That's the problem. I don't know. It's all fucked. Yo, what's up, ADS? Okay. All right, here we go. Yes. Okay, cool. Okay, there we go. T2 equals mg over sine. Yeah, here we go. Okay, so now everything's only in terms of two variables, right? We have T2 and then T1. That's two variables we gotta solve for, and we got two equations, so we're great. Does this make sense so far? To who asked this first? Sorry, who was this? One second. Let me go through my chat. Where are you, chat? Where did my chat go? There it is. Sancheesy. Oh, he seems it off. Okay. Let's see what we actually get from this. So I can solve for T2 right away here, right? T2 is just equal to, if I move this over, this is just mg over the sine of 60 degrees. So, where's my calculator? I need my calculator. Sine of 60 is square root of 3 over 2, I think, but I don't know what that is, like in terms of numbers. Okay, calculator. Okay, m was 10 times 9.8, so that's 98 divided by the sine of 60 degrees. So that gets me T1 is equal to like 113 or T2 is equal to like 113 newtons. Which, was that any of the answer choices so far? Oh, I see. The 116 is what it is. Oh, okay. I wonder. So again, I took this question from another friend's who's a professor, 5A class. I wonder if they use 10 for 9.8 instead of. Let me see if they do that. They may use 10 for G. In that case, that would be 100 divided by the sine of 60, which is 115.47. It gets closer to 116, but it's not exactly right. No one uses 10. They shouldn't be using 10, but apparently this professor uses 10. And even when they use 10, they're still kind of off. Okay, so yeah, whatever. Okay, so then T1 is equal to T2 cosine of 60 degrees. That comes from this. And so if we do this times the cosine of 60, we're going to get 56.7. So I think the answer choice was basically just A. It's close. I mean, this is the one this is definitely the closest. If there was a choice F here, which said like none of the above, then that would cause problems. But we didn't do that. Yes, I'll go through all the questions. Let me go through them like one at a time. I see all the questions in the chat. Wow. Thanks, Cheesy, for the sub. You a G, dude. Okay. Yes. Just like in office hours. Yeah, I have to. There's like a queue. Anyways, does that make more sense to you, at least? Yeah? All right. Let me go through more questions. Right there. Okay. All right. Okay, Priyana had one about the last question of the practice final exam. Are you talking about the FRQ, Priyana? You're welcome, Sancheesy. Last question of the final practice exam. I assume that's the FRQ. Let me go find it. Let me dump this in here so we can just see it. What's up, Shantrix? Okay, cool. Last practice. Okay, let me go figure it out. What up, Recky?
Good job.
Recky's like, I can't lose my streak. I realize, yeah, I apologize. I didn't tell anyone in my Discord that I was streaming today. This is mainly just to help students with the UCLA final. Where am I going? Okay, here. All right. Last question. Do I know FizzBuzz? Yeah, I know FizzBuzz. And, I rated them a couple times. It's cool, dude. He just started streaming though, I think, right? He's kind of new to the streaming sphere. Let me pull that in, not kudu. And then we want this, use conservation energy to determine the maximum height. Is there an answer key with the bonus? There is not, no. I didn't have time to write answers for the bonus. And also the bonus is bonus. It's meant to be a challenge. If we have time today, I'll go through them. I'll go through the bonus ones. Why am I seeing canvas in the summer? Because it's not the summer, Laz. Laz, this is technically the end of the spring semester. Okay. Well, I think I have to use part 1 first, right? Yeah. We need step 1 before I can do step 3. Okay, so I got to do it anyways. Okay. Put the calculator away. All right, one sec. Let me go through chat real quick with Priyana for question 4, step 2. Okay. Okay. Oh, you met him where you at UCSD at a bonfire. That's cool. So it's funny. Some of these questions that I used for the practice final came from my friend who's a physics professor down at UCSD. She just started though last year or 2 years ago. Okay, let me see what Priyana was asking about there. Part 1, the height is it just 1.3? All right. Do people need me to go through that, or can we just assume that? Yes, I'm only doing practice final physics questions today. Yeah. But I figure if you want to, like, you know, follow along and learn some physics, you can. Oh, wait, sorry. My questions were for FRQ4 with the rod and the ball. Okay, no. Okay. Sorry. This one. Okay. All right, let's do this one. Got you. Oh, you're still in contact? Yeah, her name, the one I know, their name is, oh, man. Gerline. Gerline is her name. Oh, what's the change in kinetic energy? Okay, here we go. Again, I think I need step 1 and step 2 to do this. Whatever, let's just do the whole thing. Let me get step 2. Yes, Daniela, we can. Well, thank you. What's up, Sam? Or Dawn? Thank you. I do need to hydrate. All right. Okay. Whatever. I'll just run through this whole one. And then, Daniela, we can go through the one. All right. Okay. So, angular momentum of the rod about point P right before the collision. Okay. So, right before the collision, you have rod, right, which is moving with, like, some omega. You have the point mass here that has omega equal to 0. And so what we need is L total equals L of the rod plus L of the ball. L of the ball is 0 because it's not moving. Where gravity will cancel mathematically. Yeah, G cancels sometimes, yeah. L of the rod is 1/3 m1d squared. And then this is times omega. And this is equal to L total. Okay. Then after the collision, this thing is stuck. So it's not going anywhere. So you just have M2, which is moving, all right? So now this has omega equals 0, but this has some new omega. Which, yeah, we will then learn to get the speed of the ball. Okay, oh, well, the first question just asked for what's the angular momentum before the collision. Okay, well, it's just this. So that's 1/3 times 2 times the distance of the rod, or the whatever. No, sorry. This one's 4, not 2. Sorry. 4 kilograms. And then this is 5. Is the omega, and then D is equal to 3. Man, all these variables. Okay. I think I got that right? So the 3's cancel. V equals IR. Wrong class. Okay, L total. It says equal to 20, and I forget the mu units for this. What is it? It's like kilograms, meters squared, radians per second, or something. I think it's like Newton kilograms or something. Yeah. 3 squared. Oh, thank you, Fem. This is actually 60. Fem, always good. You're good on the catches, dude. I appreciate that. Yeah, sorry. This was 3 squared. It was 1/3 M1 D squared. So that only cancels out one of the 3's. So then you have 3 times 4 times 5. So this is 60. Okay. Sebastian says, I have to study for a final tomorrow in a class I did not attend due to me being in a mental health facility. Uh-oh. How can I study a whole semester of physics in one day? You can't.
Oh, no.
Yeah, I don't know. Do practice problems, maybe. But that's hard, man, dude. Okay. So if this is 60 before, then the speed of the ball right after the collision, well, that means that the angular momentum before the collision has to equal the angular momentum after the collision. And here, same thing. You have L of the rod plus L of the ball. But L of the rod is now 0. Because it's not moving. And then this is going to be for the ball, which is going to be, again, I omega. A ball is like a point mass, which is going to have I equal to mr squared. And then omega here is just going to be omega. But what we usually like to say is that omega is equal to V over R. So I can replace this with V over R. This is going to cancel. And you're just going to get MRV. Units, I'd literally deduct half points for real for no units. Yeah, but angular momentum's like a weird units one. I'm not gonna get too mad about that. Yeah. The bullet is also a point mass. Sorry, it's not a bullet. Sorry, it's a ball. But yes, the bullet is also a point mass. Yeah. Anything is like really small and like moving, we just consider it to be a point mass. So R's radius, good, and that's the distance of this from the point of rotation, which in this question, that distance is D. So technically this should be mdv, if I really wanted to be like consistent. So you're gonna get 60 is equal to the ball, which is 2, times D, which is 3, times V. So you get 60 is equal to 6V. So V is equal to 10 meters per second. You should know these units. You should know velocity at least. I honestly don't remember what the units are for angular momentum, but okay. So then, what's the change in kinetic energy? All right. So kinetic energy, right, can have like 2 different forms. You can have like linear kinetic energy, which is like 1/2 mv squared, and then you can have rotational kinetic energy, like which is 1/2 I omega squared. Okay. At the beginning, this is not moving, so there's no kinetic energy from it. The rod is, right? And the rod is like rotating. So I'm really just going to look at the rotational energy of the rod, because the rod isn't like this swinging thing is not also moving to the right, like translationally linearly. What's up, Descendant Fonts? What's usually the backbone in deriving every or most formulas in undergraduate physics? Probably kinematics and F equals ma. You can derive almost anything for mechanics from the position equation and then from F equals ma. If you use calculus, that's cool. Anyways, so Gerline's not a prof? Oh, she's not? What is she? I'm pretty sure she's a prof. Oh, she's a lecturer. No, I think she's like, but she is tenure tracked. She's a better teacher than most official professors. I'll tell you that, like, real quick. Because she actually cares about teaching. 1/3 m1d squared. They have like her position, I think technically is called a teaching professor, is what it is. So she doesn't do like grant money stuff, but she just focuses on teaching people. To be tenure, you have to be assistant professor. It's a new thing, ADS. It's a new thing, them doing tenure track like lecture positions. Okay. All right, we have this. Do we understand this so far? Okay, ADS, but they are. They are in this case, yes. Usually they're not. You're right, ADS. Usually they are not. Yeah, okay. You're a postdoc at Columbia? Yeah, I know too. Well, okay. I'm telling you, it's a new thing, ADS. It's new. It's a new thing they're doing because they need people to actually teach at universities. Okay. Kinetic energy afterwards. Okay, I've been in academia for the last like 20 years. Do you wanna have like a dick throwing contest here, dude? Like what? 1/2 M2. M2 is 2. Okay. So this is just of the rod. This is going to be of the ball, because this is before. So before, the only thing that has kinetic energy is the rod. Because that's the only thing that has motion. Afterwards, the only thing that has kinetic energy is the ball, because that's the only thing that has motion. So this would be 1/2 M2 V squared. You studied this when you were 12? Congrats, dude. So 1/2 times 1/3 times M1 is 4. And then D here is 3. And then omega here's 5 squared. And then the ball is 1/2. M2 is 2. And then we figured out what the V was after the ball gets hit. And that's 10. That's 10 squared. So this cancels, this cancels. Oh, actually, but we want the change in kinetic energy, right? That's what we want? Okay. So you have to figure out what the total kinetic energy here is at the beginning, which is just the rod. Is it? This is curriculum. It is, yeah. So this cancels with this. So 1/2 of 4 is 2. So you get 2 times 3 times 25. So that's going to equal to 150 joules. And then here, this cancels. And this is just 100 joules. So your change in kinetic energy is equal to negative 50 joules. You lose 50 joules going from here to here. Yeah. Does that make sense? Who asked this one? Priyana, you asked this one, right? Let me know if that makes sense to you. Let's see what else we got in the chat. Yes, cool, awesome. Okay, one sec. I'm going through the queue. I should have set up like a form. Usually people just wait until I finish a question to ask the next one, but I understand it's probably a list. Yes, Daniela. What was your question? Was about number 3. Is this MCQ3, right? Oh, I see. I see what you're talking about. Yeah, okay. Got you. This one. Yeah, okay. So.
Nice.
Cool. So here we have the ball being launched at a velocity of 4 meters per second. What's up, Masan? Okay. Which means it's going to have components, right? So you're going to have Vx and you're going to have Vy, all right? Vx in this case, if this angle here is 30 degrees, this is going to be equal to 4 cosine of 30 degrees. And then Vy here is going to be equal to 4 sine of 30 degrees. Cool. And we're trying to figure out the maximum height above the ground. Okay, so when this ball is launched, right? It's gonna like eventually reach some maximum height here. So we can call this, I don't know, like situation. I'll call this like situation 2. And then eventually the ball reaches some maximum height here, which I'm going to call situation 3. And this is like at max height. Okay. So conservation of energy means that we have to add up what all the energies are in a certain situation. Okay. So, here, the ball is going to have potential energy due to gravity, right? So, let's just do this. You want me to do part 2 as well? Yeah, I can do part 2 as well. Actually, interesting. Yeah, here, let me do this part, and then I'll do part 2. I forgot that the speed here is the same as the speed here. It's actually kind of cool why that is. Okay, so you have UG, which is equal to MGH, which in this case is equal to 0.1, 9.8, and then the height that this thing starts at is 0.5. And then you have kinetic energy, which is equal to 1/2 mv squared, and that's equal to 1/2, 0.1. And then this has a velocity starting 4 meters per second. So this is 4 squared. Okay, cool. Now, it's situation 3, when this thing is at its maximum height. Okay? It will have mu g equal to mg, and I'm going to call this like h max. Okay? So that's going to be 0.1, 9.8, and then h max. And then it still has kinetic energy. And this is where the cosine comes in. So at its maximum height, the velocity in the y direction has gone to 0. Because it can't go up anymore, right? Maximum height occurs when Vy is equal to... This is always... Maximum height's always when Vy is equal to 0. But it still has Vx. It's still traveling this way. How long is the stream going on for? I don't know, probably like 2 hours, 3. Whatever you guys want. I'll try to answer everybody's questions. I will get hungry eventually, though. Okay, how do we know when to use components? Okay, so anytime something is moving in 2 directions, you 100% need components. You're right that when we did 1D kinematics, we only worried about like v was equal to 0, but that's only when things were moving up and down. In this case, things are moving to the left and the right as well, moving up and down. So you need to consider the components of the velocity. And maximum height only occurs when the y component of the velocity is equal to 0. Okay? The x component of the velocity does not change because there is no forces in the x direction. Remember that like F is equal to ma, which is equal to m like delta v delta t, okay? So if there is a force in a direction, then there will be a change in velocity in that direction. What's up, Quark? Is this stream recorded? Yeah, everything's recorded. Everything you do on the internet is recorded. But yes, I'll post a link to it as well if you want to go through it at some point. Anyways, so Vy is 0 here, but this ball is still moving to the left with a velocity of 4 cosine theta. So it still has Vx is equal to 4 cosine of 30 degrees. So when I come down here to do my Quark. Quark, I'm just doing physics questions today, unfortunately. But if you want to, we have a whole other slew of other awesome math streamer friends that do math. There you go. Yeah. Where do erase things go? They actually don't get erased. You know, they're just like not accessible. If you actually want to erase your data on a hard drive, you have to like degauss it. Anyways. Okay. Kinetic energy, 1/2 m, and then this is going to be v squared. But the velocity is only in the x direction. So this is going to be equal to 1/2 m vx squared. So that's 1/2 times 0.1 times 4 cosine of 30 degrees. And then this is squared, right? Because the velocity is squared. 4 cosine of 30 squared. You're so underrated. Thanks, bro. I don't want... Underrated in terms of what? What's up, Max? Okay, so now what I do, right, is I say that this total is equal to this total. Which is kind of a mess, honestly, right? Because, I don't know, we got like all these numbers and shit. Okay, I have to figure out what this total energy is. Unfortunately, you do have to use a calculator at this point. I like when things just like cancel. I guess the mass cancels. Yeah, the mass does cancel. Watch this. This is actually cool. So 0.1, 9.8, 0.5. That's the MGH plus 1/2, 0.1, 4 squared is equal to, what is this? 0.1, 9.8, H max plus 1/2, 0.1. And then this is 4 cosine of 30 degrees squared. All the mass terms, these 0.1s are all going to go away. I don't need any of these. Yeah, I do need to update that list. You're right, Descendant Fonts. Yeah, because Danny doesn't stream anymore, unfortunately. I miss Danny. Bring Danny back, dude. And Danny got, like, a little discouraged with, I think, life. I miss Danny, though. Okay. And this is 9.8 H max. And then this is plus 1/2 4 cosine of 30 degrees. But then it's all this squared. So it's really like 16 cosine of 30 degrees squared. But okay. Then you can do math here. So we can do 9.8 times 0.5 plus 8 minus 1/2 times 16 times the cosine of 30 squared. This equals that. And then we divide it by 9.8. And I guess we get 0.7. Was that the right answer? 0.7 meters? me see. Is that what I got on the... I think I did it. Yes, his philosophical rants were the best. Dude, Danny would have so much to talk about. Yes, we did get 0.7. Nice. Okay, cool. I agree with that. Okay. All right, so that was 0.7. Nice. Cool. All right, step 2, which was asking about the, I don't know, I think it was asking for the normal force on the track here, right? So, if you have mass here, right, or let's make it like solid. Mass here is solid, and you got a couple forces. So we got force normal pointing to the right. I got force of gravity pulling down. That's it. And I want to figure out normal force. Well, I also know that there's centripetal acceleration pointing in this direction, right? So if I were to write out the sum of forces in the direction where Fn is, because that's what I'm trying to figure. I'm trying to figure out Fn, so I want the sum of the forces in the Fn direction. I'm going to say, okay, cool, sum of forces in the x direction. Well, that's going to be minus Fn. That's the only thing pointing to the left. And then that has to be equal to ma. Now, this thing does have acceleration in the x direction, and that's equal to ac. So I can say this is equal to m ac, which, yeah. It turns out there also is acceleration in the y direction due to gravity, but we don't really care about the y direction stuff because all we are concerned about is finding Fn. So, oh, and also this is negative because AC is also pointing to the left because it points towards the center of the rotation. So that then tells me Fn, we get rid of the negatives, is equal to m, and then AC is v squared over r. M I know. R I know, right? R is equal to 0.5. And then we just need v squared. Now, here's a cool thing. They tell me here, right, that v is equal to 4 meters per second. It turns out because these things are at the same height, do you see how this is at 0.5 and this is also at 0.5? That means that this object and this object have the same gravitational potential energy, right? So here, right, mu g is equal to mg times 0.5. And then here, mu g is also equal to mg times 0.5. So since they have the same gravitational potential energy, and they have to have the same total energy, it means their kinetic energies are the same, which means their velocities are the same. So I can instantly just say, oh, well, the velocity here is also equal to 4. And now that gets you Fn. So what? That's, sorry, that's 16, 32. So I think that's like 3.2 newtons. Is that what we got? Yeah, 3.2 newtons. Nice. Okay. Does that make sense for part 2? How we did that one? It's just mv squared over r. And then the clever thing you have to realize is that the velocity here is the same thing as the velocity here. Because, so answers to part 1 and part 2 of your question is no. What's the no part, Fembox? Yes, cool. Yay, good job. Good claps.
Well done! Well done!
All right, let me see. Could you also get velocity by setting situation A equal to situation B and solving for V? 100% you could. But that would take more time. It's more clever to just realize that situation C and B are the same. Yeah. Oh, okay, all good. Can I do the bonus for this as well? Yeah. Okay. Yeah, let me do the, just because we're here, let me do the bonus for it real quick, guys. And then I'll do the other one. Okay. So the bonus, I think, asked, what did it say? Wow, I gotta go find it. One sec. Oh, from Quark. Oh, you're good. Fuck, where is this question? Oh, here it is. Okay. If the entire track had a coefficient of friction of 0.1, what would be the new height? Okay, cool. Interesting. Okay. So now what I'm going to do is, so I'm going to equate what the energy here is at the beginning to what, oh, I see why this gets harder. We gotta solve for what the new velocity would be here. And then we can do that to then figure out the maximum height. Okay, so like, say, assume friction. Okay. My goal is to find VC. Let's find the velocity at C, and then we can do our same thing. So, at point A, right, you just have gravitational potential energy, right? You just have mu g is equal to mgh, which I think was 0.1 times 9.8 times the height. Was the height 1.3? Is that what we said it was? I think that's what we solved for the first time. Okay, after the block slides down, here we go, one sec. After this block slides down, this part, it's going to lose energy due to friction. And so we're going to have, let's call this like energy friction A, and that's going to be equal to the force of friction times the distance that it travels there. Okay, 1.3. Thanks. Okay, cool. So now I have to kind of like draw like a force diagram. So if this is mg pulling down, right, we know that friction's going to point this way. You got a normal force here, but this is equal to mg mg cosine theta, right? Because this is theta, and this is mg cosine theta. This is fm. Okay, cool. So then this is equal to mu k fn times d, which is equal to 0.1. Also 0.1, which is the mass. 9.8 cosine of 30 degrees times d. Now the D is a little bit tricky here, right? Because I need this distance, right? But to know that distance, right, I know that this height here is equal to 1.3, and I know this is equal to 30 degrees, right? So distance, right? So I can say that d sine of 30 degrees is equal to 1.3, right? So then d is equal to 1.3 divided by the sine of 30 degrees. So that's the distance that this thing will have friction robbing energy from it. So then this becomes, for d, this becomes 1.3, and then this is over the sine of 30 degrees. Oh, this is cool. This is cotangent. Okay, cool. So that's energy lost to friction at part A. And then now the energy lost to friction here, we'll say at section C, that's going to be the same thing. Force of friction, it's actually all the same shit. The only difference is that the distance now is not 1.3 over sine 30. It's 0.5 over sine 30. Because that's how we figure out this distance is shorter than this distance. So this is the same thing, mu k fn d, except d is now 0.5 over sine 30. Does that make sense, Darren? We're going to get to it. I'm just calculating what it is. It's negative depending on like where you put it. So let me show you what I mean by that. And then this is 0.5 over the sine of 30. I know that it seems more steep, but we said it's 30 degrees. We said it's 30 degrees. Okay. So here's what happens. So in situation A, you have this, right? You just have MGH. Now for situation C, right? You're going to have kinetic energy, which is equal to 1/2 mv squared. You're going to have gravitational energy, which is equal to mgh. And now you're also going to have energy that was lost to friction. And that's going to be equal to E fric A plus E fric C. Yeah. Yeah, never trust drawings for like scale. That never works. Yeah, most diagrams are definitely not drawn to scale. Yeah. They're almost never drawn to scale. No. Physics people do math. They're not artists. I mean, I think I'm kind of an artist, but most people aren't. Okay, anyways. So, yeah, you're right, Darren, that the energy is lost, but that's why we put it on the right side here for at C. Because what we're saying is that, okay, at A, right, you had a bunch of potential energy, you had no kinetic energy. And then at C, now we're going to have less potential energy, right? Because we're shorter. So some energy here dumped into potential. We're also going to have more kinetic energy. Again, not to scale, because some energy had to go kinetic, and then some energy had to go to friction. Some of this had to get dumped into all the friction. So energy starting here ended up dividing itself or spreading itself into 3 different sinks. Yeah, during waves. Yeah, optics is the worst, dude. Yeah. So that's why, Darren, it's a positive thing here, because if I put it on the right, it's like plus this. Like the more there is of this, the less there is of this. And that should make sense. The more energy you lose to friction as you're traveling, the less energy you get to keep in potential energy and kinetic energy. So this is 0.1, 9.8, 1.3 is equal to, so this is going to be 1/2 times 0.1 times v squared. And then this is going to be plus 0.1 times 9.8 times the height, which is 0.5. And then we have the energy to friction, which I'm going to do some real simple maths. I'm going to do a lot of math approximations here. This is 0.1, 0.1, 9.8. Cosine over sine is cotangent. I'm going to say cotangent of 30 degrees. And then it's going to be 1.3 plus 0.5. The reason for that is, do you see how for the friction terms here, Darren, that it's basically all the same numbers? The only difference is this is a 1.3 and this is a 0.5. So I can factor all that stuff out, and then it's just 1.3 plus 0.5. So this is our final thing we're looking at. So this is 1.8. Okay. Now I gotta solve for this huge mess. Where's my calculator? Okay. 0.1 times 9.8 times 1.3. Cool. Minus 0.1 times 9.8 times 0.5 is that. And then I say minus 0.1 times... I could have canceled one of the 0.1s, honestly, but whatever. 9.8. Was it? Make sure we're in degree mode. Good. Oh, but there isn't a cotangent in this calculator. It's always dumb. 1 divided by tangent of 30 times 1.8. Yeah. Unfortunately, yeah, they are this is still a mess. You still have to do this. Okay. And then I'm going to divide this by 1/2. And then I'm going to divide it by 0.1. And then I'm going to take the square root of this. So then you get your velocity is equal to 3.09 meters per second. Okay. So now v is equal to 3.09 meters per second. So that's the velocity of it at point C, which you can double check and be like, okay, does this make sense? Because without friction, the velocity at point C was 4 meters per second. And I'm like, cool, yes, that does make sense. Because with friction, the velocity should be less than if there wasn't friction. Okay. So, yeah, the next step is to then do this again. But instead of 4 here, you have 3.09. Dr. G, MCQ2, please. Yeah. All right. Let me wrap this first. Let me just make sure we got this for Darren. Okay, so if I then do this, but with my new number. So 9.8 times 0.5 plus 8 minus 0.5. And we're going to say times, this is our new velocity, squared, times the cosine of 30, squared. Cool. Divide by 9.8. Well, I shouldn't go higher. 1 sec. Ugh. I did something wrong. 9.8 times 0.5 plus 8 minus 0.5 times, what was it, like 3.0, 9 squared times cosine of 30 squared, 9.31. Yeah. Would you ever drop the lowest midterm or curve as a professor? I don't believe in curves. I think curves are terrible. Because you get like students like competing against each other, and they don't want to help each other. If you have a curve, people don't really worry about learning. They just worry about doing better than the person next to them, which is, I think it's so wrong in a class. So no, I don't curve. I kind of enact curves by, I'll sometimes drop questions. Like, if everyone got a question wrong and I need the class average to come up, I'll just drop a question that everyone got wrong. That's like my curve, but that's not guaranteed. 1 sec. Why am I getting the wrong number here, Darren? What's wrong with this? We got 0.7 here, which I was cool with that. Oh, wait a minute. Yeah, I should be getting a bigger number. Why don't I get a bigger number? Right, because when we did this... Do we need to be well-versed in bank curves problem? Ooh, no comment. Do you have your practice exam posted on Discord? I don't. I could post it for you, Femvox. I could post it for you. I don't know how to do... Yeah, I don't know how to do links here with this. Sorry, I need to make sure... I'm, like, losing my mind here. Why this is wrong. You get HMax 0.37. I agree. It should be less. Okay, cool. Is that what you also got? I think there's an input error somewhere. Yeah, but I'm getting too tired to look for it. So, okay, cool. It's 0.37. Yeah, this is the important part. And then, like, doing the other thing is just cake. But, okay. What's up, smiley face? Let me see, Femvox, if I can give you the final somehow. Let me download that. And then, here, I'll post it. Can I just, like... Yeah, there you go. Okay. There you go, Fem. I sent it to you. Or I tagged you. I just got an ad from reloading the stream. Really? Ads? I shut off ads on my Twitch. I don't believe in ads. No, I got you, dude. So, Aliyah1, usually this is for anybody in general, but today this is a special stream just for my UCLA physics class because they have a final exam tomorrow. But, yeah, if you want to know... Here, let me... if you want to know when else we're streaming, and you can just get general help, that's on during the week. Where's my chat? Chat. Here. So if you go to this, that has our calendar when we stream. And so if you click on it, you go look at it. Yeah, go to site, please. You got an HMax of 0.626. Oh, well, I don't agree with that. But this is the schedule. Yeah, good luck on them. Yeah, thanks, man. Okay, one sec. We gotta resolve this because now we're getting two different answers. You got an HMax of 0.626. Why is that? One sec. Oh, you know why? Okay, this is where the fuck up is. Sorry. I see it. I forgot that I have to change this velocity as well. Sorry. Okay, here we go. This is... Got it. I got it. This is the... I was getting too clever. This is now going to be 3.09. This is also going to be 3.09. That was what it was. I was flipping it here, but I didn't switch it here, unfortunately. That's why things were going wrong. Okay, so this is different, because this won't be 8. Okay, one sec. 9.8 times 0.5 minus 0.5 times 3.09 squared minus 0.5 times 3.09 squared times the cosine of 30 degrees squared. Oh, that's negative. Well, that's not good. There we go. Okay. 6. Now I divide this by 9.8. Got it. Sorry, it's just input errors. I fucking hate it. It's just like, what? Yes, 0.62. HMax should equal 0.62. Good. There you go. Cool. Oh, are you having office hours tomorrow? Good to see you, Elizabeth. Am I having office hours tomorrow? I think I will. I'll announce that later tonight. Because, yeah, I went in yesterday to campus to go print all 5,400 pages of this final. Because it's 30 pages per final, and I printed 180 exams. So it's 5,400 pages, which I figured out is half a tree. We killed half a tree printing this final exam. For those that want to, like, I got a picture of it. It was so much paper. Look at all this paper. That's one stack of the final, and this is both stacks of the final exam. 30 pages, we are cooked. No, I just gave you guys a lot of space. You're not cooked. I just gave you a lot of space on the exams. Because I knew people were going to need space to write their work, so I spaced them out. UCLA exams aren't computerized. If they were, dude, there would be massive cheating problems. Eventually, like, we just have to make things pen and paper, because it's the only way to make things fair. Because, yeah, dude, I have online homework. We have online whatever stuff, but you can chat GPT fucking everything. The only thing you can't chat GPT is, like, a pen and a paper sitting at a desk. Can you show us the first page? Yeah, I mean, yeah, I can show you the first page. There you go. That's the first page. See? Page 1. That's the first page for you. You could secure that. You could. Yeah. You could, Jeff, but the issue is that it's cat and mouse. Kids always find a way to cheat. They always do. University issue computers with screen recording for the session. Yeah, maybe. Like if we gave them, but like, does the university have 188 laptops to hand to people? I guess if you had like a testing center, Jeff, maybe you could do that. Yeah, you could do that for sure. I don't know. UCLA is already apparently like bankrupt, so I don't see them doing that anytime soon. Okay, sorry. Let me go through the whole chat. MCQ 19. Save the state of California some money, dude. Yeah. Well, they don't even have enough money to hire me in the fall, dude. So, fuck. Although I don't know, they apparently have enough money for all the admin. So, all right. Sancheesy keeps saying like multiple choice 19. I'll do 19, and then I'll do multiple choice 2. I know that's another hot one people are talking about. So hot right now. Oh, not all this. Go away. Okay. A car traveling with a velocity v can stop a minimum distance d. What would be the car's minimum stopping distance if it was traveling at a velocity of 2v? This is a good question. So, let's say you have object here traveling at velocity v. And then after a bit, it comes to a stop, right? So, let's say velocity is equal to... I hate that it's all v equals v. Is v. One sec. Let's just say v naught. I'm going to call this v naught. Or we're going to say v equals v1. And then here, v is equal to 0. And it travels a distance d. Right? So, energy here is just kinetic. So that would just be 1/2 mv squared. And then afterwards, there's no 1/2 mv squared because it stopped. Also, we assume mgh is 0 here. So all you have here is the energy due to friction. So what happened, right, on like the little graph of things, right? So here you had kinetic energy. Mu g was 0, whatever. And then afterwards, kinetic energy, mu g, but now we have energy lost to friction. Okay? So this energy here had to get dumped into friction in order for the kinetic energy to go down. Energy in the friction had to go up. So that's what happens. You have kinetic energy turning into frictional energy. And frictional energy, right? That's equal to mu k Fn times d. Okay? So that tells you right away that if we say energy here is equal to energy here, that 1/2 mv1 squared is equal to mu k Fn, and let's call this like d1. Heating the block, yes, or heating the ground, Jeff. It heats the ground is what it does. I guess it kind of heats the block. Okay, so now we have a new situation where the velocity is now twice what it used to be, okay? So now we have the same situation, but with a new velocity, v2, and that's going to go a new distance, d2. But v2 is equal to twice v1, right? Because we said now it's going twice the velocity it used to be in the first situation. So I can sub that in for here. And so now I get 1/2 m, and then we're going to say this is going to be 2v1 squared is equal to mu k Fn d2. Cool. This is like situation 1. This is situation 2, but then this is like modified situation 2. So now if I divide this by this. So here's what I'm going to do. I'm going to take this whole thing here. And I'm going to divide it by this whole thing here. Watch what happens. So all of this stuff goes away. This goes away. And you're left with 4 v1 squared over v1 squared is equal to d2 over d1. v1's cancel. And so you get 4 is equal to d2 over d1. So then d2 is equal to 4d1. Is that what they're asking? Were they asking for d? I think they were. Yeah. Okay. So that tells me my new distance is 4 times what my old distance was. And so, really the smarter way to do this is you recognize all this other stuff here. These are constants, right? Like they don't affect things. If I ramp my velocity up, my mass doesn't change, right? My normal force doesn't change. My coefficient of friction doesn't change. So really, we could have ignored all this and just said, okay, well, v squared is proportional. This was this little goldfish looking thing is. V squared is proportional to d. All right. That means if velocity goes up by a factor of 2, this goes up by a factor of 2 squared. If velocity went up by a factor of 3, then the distance would go up by a factor of 9. And vice versa. If this goes down, like let's say by a fourth, this would then go down by a 16th. This is why speeding even a little bit is bad. Yes. Yeah, correct. So yeah, you bring a really good point here, Hamiltonian dynamics, which is yeah. So if you double your speed, it takes 4 times the distance for your car to stop. So it's not linear, yeah. But this is the quick way is to recognize that v squared turns into d because everything else is constant. But then this is the more, I say like rigorous way to do it, which is just write out what it is for one situation, write out for the next situation, and then relate the velocities between the two situations. And then you can divide one by the other to basically get what d2 over d1 is. And this is the ratio of the distances. This is saying d2 over d1 is equal to 4, or if you cross multiply, d2 is equal to 4 times d1. Does that make sense? I forgot who asked that one. Wow, what's up, Sam? Thanks, dude. I do need to drink some water. Okay. Okay, sorry, one sec. Oh, none of my chat updated. Sorry, let me get through all my chat. I always get clapped by the MCQ. Oh, no. Sancheezy, we're gonna miss you, Dr. G. You've made physics so fun and a hard class actually understandable. I think we should all sign a petition to have you stay. I say, like, yo, if you want to go email the department chair and just be like, give this guy a job, maybe they would listen. I don't know. I forget. Who's the department chair? I think his name is Stuart Brown, maybe? Let's see, department chair physics. There you go. Yeah, this guy. Here, you can go. I feel like I'm doxing somebody, but he's the chair of our department, so if you want to go tell him I should teach, you can go email him or something. If he got enough emails, he might actually, like, change his mind. Or maybe they would look for an opportunity or something. I don't know. I'm not getting kicked from university. No, they just don't have funding. UCLA's in not a good position right now. I think I saw something about, like, Trump wants to cut all of, like, UC. Oh, dude, there's so much going on in LA right now. Outside my doors, Trump, UC funding, California funding. Like, number one, like, UCLA is in debt, and then there's also this, apparently. Trump is preparing for large-scale cancellation of federal funding for California. Uh-oh. So there goes even more money. LA is crazy right now. I agree, Sam. It is crazy. Okay, so why did we equate kinetic energy to energy friction on both sides? Would you subtract friction from that energy? I like to always put friction on the right, is what I like to do. I always like to... Again, we did it. I think we did it... Where did we do it? We do it here? Where did we do it? In this question... Was it this question? Yeah, it was here. So when we had the thing, you know, start at a certain height, and then it went through all the friction, and then it ended up somewhere else, wherever it ended up, I like putting the friction on the right there. You could have put it on the left here as, like, as minus terms. And then you would just say this equals 0. Bro, we're done for. I don't know. Have hope. I have hope that America can sustain itself through some interesting times. But yeah, we'll see. Newsom wants to stop paying federal taxes. Dude, that's about to be absolutely nuts if that starts happening. Not even in UCLA. I'm going to email him. Oh, I appreciate that. Okay. All right, let me see. What other question did we want to go over? I think it was MCQ 2. You guys want me to do MCQ 2? There we go. Okay. Nope, not this. Okay, it says a bullet of mass 2 grams is moving horizontally with a speed of 500 meters per second. The bullet strikes and becomes embedded in the edge of a solid disc, and the radius this. The disc is free to rotate. What is the angular velocity of the disc immediately after it's embedded? Okay, cool. So, I like to think of, let's think of 2 situations here. You just got stuck on this one? Okay, fam, we're gonna go over it, yeah. So, here you have bullet, right? Which is moving with a velocity 500 meters per second. And then the radius is equal to 0.5. I guess I should have done this on both of them. Whatever. That's kind of the center-ish. And then this has a mass of 2 grams. And then this has a mass of 3.2. Okay. So, angular velocity. Anytime I see, like, asking about angular velocity and it's like before and after a collision, we want to use conservation of momentum. So this is conservation of angular momentum. I of the disk is 1/2 mr squared. Yeah, I would give that to you on a test. I would have to tell you that. Sorry. This is equal I of a disk. Okay. So if we're trying to figure out, and then so initially here omega is equal to 0, and then in this final situation, the bullet is here, and they're all moving together with some omega. All moving with like some omega equals like question mark. Okay. So, angular momentum, L total. That equals L of the bullet plus L of the disk, okay? The disk is initially not moving, right? It's just chilling. So that means the angular momentum of the disk is 0. This goes away. We don't have anything. Here, we'll make it pink. None of this. Now, this is where students get tripped up sometimes, because if we're asking for the angular momentum of the bullet, they start thinking, well, wait a minute. That would be equal to I of the bullet times omega of the bullet. And this bullet is not rotating, right? Well, it turns out anything has angular momentum if it is moving perpendicular to the radius to the center of rotation. Why psychology so much reading? Because it's psychology, bro. What? You think it was going to be numbers in psych, bro? So what I like to imagine, I say, okay, instead of the bullet being out here, let's imagine the bullet right before it gets stuck, okay? So right before it gets stuck, it still has a velocity equal to 500 meters per second. And this looks like a point mass to this center rotation, which has a moment of inertia, which is equal to mr squared. Okay? So, when I'm calculating here I of the bullet, now I have mr squared. And to get omega of the bullet, right? This is where this is a little tricky. Harder questions will definitely be in the FRQ. There might be like one hard question in the MCQ. Okay. So, yeah, exactly. So to get omega of the bullet, we remember, right, that omega is equal to V over R. Yeah, exactly. It is just MVR. Yeah. Yeah. So now we have V over R. So this cancels out, and this just becomes equal to mRV. Which is going to be, so the mass of the bullet, this is tricky. They gave it to you in grams. So you need to convert this to grams, to kilograms. So this is 0.002. The radius is 0.5. And then the velocity is equal to 500 meters per second. Yeah. And then you just set it equal to L total here, right? Which in this case, again, you still have the same thing for the bullet. So we're going to have little m r squared. And this is like times omega. Let's call this like omega 2. And then it's plus 1/2 big M r squared omega 2. Because they are both moving together at the same angular velocity. So final L total is equal to L of the bullet initially. Correct. Yes. So then here, this is, again, 0.002, 0.5, and then plus 1/2 times 3.2 times 0.5, and then all of this was times omega 2. So I pulled the omega 2 out. Yeah. And then I just set this equal to this. So let's see what we get from that. Where's my calculator? There it is. .002
Nice.
times... Wow, thanks for the follow, dude. Times 500 equals that. Oh, nice. Okay, divided by 0.002 times 0.5 plus 1/2 times 3.2 times 0.5. Well, no, off by a factor 2 somewhere. Well, that happened. The radius 0.5, did I get that right? Why can't solving concepts like energy be as simple? Oh, I'm missing a squared. Yeah. Oh, you're so right, dude. Oh, who brought up Master Chief? Yeah, my bad. Yeah, sorry. This is squared. It's because I got rid of the R squared here. I fucked that up, dude. That's.
You gotta get in the hospital now.
I'm upset about that. Yeah, this is squared. This is squared. Yeah, I messed that up. My bad. R squared is still. R is still being squared. Here it's not because one of the R's cancels. Okay, thank you. All right, good. Let me change that. Well, that's easy. We just make this like 0.25, right? Make this 1.25. Oh, no. Oh, no, but I need...
Oh, who got baby voice started? Kid's probably really confused about things. Okay, cool. Yes, this gets me omega 2 is equal to 1.2 radians per second. Yeah, good. I get 1.25 basically, so yeah, closest answer is 1.2. This actually comes, okay, so this trick here, where we said that, oh, instead of imagining the bullet out here, I'm imagining it as if it's, you know.
Like, right on top of it here. This actually comes from what the definition of angular momentum is, which is that L is equal to R cross P, which is equal to R cross mv, which is the same thing as mass, and then it's R cross V. Is your audio broken? No, it's just someone engaged the baby voice, which makes my voice sound really high pitched for 30 seconds. It'll fix itself. So 1 second. So this is equal to like RV sine theta, or this is like M R perp V, or M R V perp. Okay. So yeah, cross product this is where the sine theta comes from, but the real way to think about it is anytime you have an object which is moving with some velocity, if you do the velocity of that times r perp, so this is the amount of radius perpendicular to the velocity to the center of rotation, this right here is r perp, right? No matter like where this block is, right? The block's here, block's here, block's here, block's here. As it's coming horizontally here, it always has r perp just equal to r. And then the other parts of it, right? MV, this is where you get MRV from. So that's one way to think. You can think about it as, oh, what happens when it's like right next to the wheel and it's about to get stuck. Or you can think about it in terms of just what's the perpendicular radius to the velocity, where perpendicular radius is the distance from this to the center of the rotation. That's what, everything has angular momentum. As long as it's moving some distance away from the rotation point. If the bullet was hitting straight on, so let's see, if the bullet, for instance, this is kind of a cool little follow-up question. If the bullet was here and it was coming straight towards the middle of the disc, then it wouldn't have angular momentum, because now r perp is equal to 0, right? If we're hitting it straight in the middle, and that would make sense, right? Because if this thing comes and hits the disc smack dab in the center, it's not going to rotate in either direction, If anything, it's just going to like cause the disc to like move to the right, but it won't rotate. Also because there won't be a torque, because the force of the bullet on the center of the rotation has no component that's perpendicular to the radius. Are these physics 1? These are close to physics. Sorry, I need some water. These are close to physics 1. These are close to physics 1 questions. Yeah. Now, I got an email from the department that like technically this is a calculus-based class. Here, I'll show you guys. Yeah. If you guys want to see, like, yeah. Also, I got this communication in, I think it must have been like a week into the class or something, or 2 weeks into the class, where they said, we're getting requests from students who have taken non-calculus based versions of 5 series classes and want to use those. So basically, like, they don't want to allow kids who have taken outside 5 series, outside physics classes that aren't calculus based and get credit for the 5 series. And so, since this may have not ever been communicated clearly to some of you, no shit, let me know that the 5 series is officially calculus based. So, this is the key part here, though. Though different instructors will differ in how much calculus they use. So, all they ask for us is, like, in the syllabus to write that it is calculus based to avoid some confusion. I don't know. It's a weird administrative decision. But we didn't do much calculus in our class, so you guys are okay. JEE prep for 2027. I'm just doing physics questions to help UCLA students review today. During the week, you can submit questions. Monday, Tuesday, Wednesday. But today's just a review. Okay, what's up? What's the next one you guys want me to go through? I'm not from America, so I've never heard this. Well, welcome, dude. Welcome to the internet. We help students from all over the place, dude. I have students from, like, Malaysia, from Belize, New Zealand, Australia, Serbia, Bosnia. That's right. I have a couple students that hop on my stream from Bosnia. It's like 4 o'clock in the morning when they hop on, but they need help. But okay, for my students, are there any other questions you wanted me to go through from the practice final, the kudu stuff, the harder kudu questions, any things? We did basically all of FRQ3 and FRQ4. And I think 1 and 2 were pretty, like, self-explanatory. Harder practice question, kudu number 3. All right, let's do it. This one. Oh, this is a very good one. Here, let me make... I want this image, like, a little bit bigger. Yeah, so Femvox, the students have, like, homework that they do as well, and so I took some of the harder homework questions and put them as things they should go over because they might be on the exam. Gotcha. Okay. Here we go. So it says a weight of 1.42 kilograms. I'm going to just do everything in terms of variables for now because I think your numbers are different based on, like, because it's randomly generated. Good to see you again. Yeah, what's up, Evanon? We're doing physics review today. Okay. Over what distance does the mass move in 3 seconds, ignore friction and drag forces, and assume that the string does not slip? Cool. I'm trying to think if I want you guys to use concept, because when I gave this question originally, you weren't aware of conservation of energy. Now you are aware of conservation of energy, so technically you could use conservation of energy for this one. But I don't think it makes it easier. Okay, so we'll just do it the old way. Okay, let's consider mass M here, okay? Mass M has mg pointing down, and then it has tension pointing up, okay? Let's look at the disk here. So the disk has the same tension pulling down on it, right? And then that is located at a distance r. I hope the orange one off the roof, I hope the orange off the roof one isn't on the exam. I don't know. That one's not so bad. I don't really think that's a bad question. One trick I've heard is you make 2 different exams, similar questions, but then print them in 4 different colors and say there are 4 different exams. Yeah, man, there are so many ways that teachers go above and beyond to try to, like, discourage cheating. Yeah, you can have, like, different exam forms, and then I've seen this before where, yeah, they'll say there's, like, 6 different types of exams, but really there's only 2, but it's to, like, bug out the students. I don't know. In my opinion, like, they don't pay me enough to come up with all these elaborate anti-cheating schemes. And I say that, like, if you're going to cheat now, okay, cool. You're just screwing yourself later. Because eventually you're going to get to a point where you can't keep cheating. And if you never learned anything, you're just going to get fucked. So, it's a temporary fix if you cheat. Cool. But you're just cheating yourself, I say, you know. Okay, nice, dude. Thanks, all I want. Thanks for coming by. Why cheat? I mean, kids get desperate. I understand what happens. It's... You know, I don't know, it's like life is rough and they're just like, but I just need to get this A, and as long as I get this A, then I won't do it again, right? They're like, oh, but it's like just this one time turns into like a habit, and then you keep doing it. If you don't want to learn, just do bad and tell everyone you don't want to. Usually either accept that or help you. Yeah, but sometimes they got pretty aggressive parents, I guess. Anyways. All right, let's describe this thing moving. Where, like, I'm going to say this direction is positive, this direction is negative, okay? So, if we look at the sum of forces in this direction, let's do it for the block, right? You have mg coming down and you have minus t. And this is going to be equal to little m times a, okay? Cool. Let's actually look at, sorry, what are we trying to figure out? Oh, we're trying to figure out the vertical distance that it moves. So eventually, sorry, let me move this. So eventually, this thing is going to move some distance after 3 seconds. So what I should try to, like, think about, like, just big overall picture before I even attempt this question is, what do I need in order to figure out how far it moves? Well, anytime I'm given, like, distance and time, I know I probably want to use one of the kinematics equations. The one that comes to my mind, right, is that y is equal to y naught plus v naught yt plus 1/2 at squared, okay? So this is the same thing as, like, saying delta y is equal to v naught y times t plus 1/2 at squared. But we know that the block starts at rest, so this is 0. So then I just have that, like, delta y is equal to 1/2 at squared. But we know t, right? We know it's after 3 seconds that this thing drops. So all I need to do is solve for a. Like, this we know. And this, we gotta, like, solve. Oh, wow, people dumped a ton of web help screenshots. Oh, what is this? Okay. So we need to solve for the acceleration. And where I see I could maybe solve for the acceleration is here, right? Do you see how the acceleration of the block is embedded in this equation when we do the sum?
Forces here. You'll never be president if you keep cheating, yeah, unless you're Trump. Keep cheating all the fucking time, I don't care. They keep giving him loans, I don't know why. Okay. In order to get the acceleration here, though, yeah, I would need the tension, right? So here, to figure out the amount it drops, I need to know the time. Oh, sorry, I need to know the acceleration. I have the time. But in order to find the acceleration from sum of forces, I need to know the tension.
So now I look at this and see if there's something about the tension maybe I could write, right? Well, I know that torque is equal to RF, or like we say like RF perp or R perp F. In this case, the rope is pulling exactly perpendicular to the radius. And anytime you have like discs and ropes and shit, the rope almost always pulls exactly perpendicular. So this is equal to RT, but torque is also equal to I times alpha. Okay? That's we learned these definitions for torque, right? We learned that torque is equal to I alpha, or it's equal to like RF sine theta. So I can equate this RF to this I alpha. So watch. So, or which RF is RT. So I say RT is equal to I, which for a disk is 1/2 big M R squared alpha. Okay. And then the key trick here is that alpha is related to A, because the angular acceleration at which rope is moving on this disk is the same as is related to the linear acceleration of the mass moving up and down. So here's the thing we learn, right? Is that A is equal to R alpha, okay? Or alpha is equal to A over R. Do Carly and I need to know number 22 on the work energy? That's hilarious. You baiting me with something? What is it? One second. Let me look and see which one that is. What was it? Was this homework? Number 22. Oh, this one. Maybe? I forget, actually, if I put this one on the exam. But it is a good one, regardless. I would definitely know how to do it, yeah. I forget. I honestly forget. Even if I remembered, I actually technically wouldn't tell you, but I would definitely, yeah, do it. Do they have to memorize the moments of inertia? They don't. No. I either give it to them in the question, or I'll give them, like, it on an equation sheet, but I usually give it in the question. Anyways. So RT, which is RF, is equal to I alpha. I is this, alpha is this. I'm going to rewrite alpha as A over R. And watch what happens here. This is really cool. I think this is really cool. So RT is equal to 1/2 M R squared. And then it's A over R. Actinium anarchy. Is actinium? Is that? No, I'm thinking of antimony. Antimony is like tin or something? Or is it? No, it's aluminum, right? Is that what it is? I'm thinking of antimony, I think. Okay, R's cancel. So then you have RT is equal to 1/2 MRA. And actually, ooh, look, the R's cancel as well. That's really cool. R's cancel. And so now you have A is equal to 2T over M. No, aluminium is aluminium, except in the UK where it's aluminium. Aluminum, yeah. Yeah, okay. So to kind of explain what happened here, I realized that anything that has an angular acceleration to it, okay, also has a linear acceleration. And linear acceleration will refer to the linear acceleration of the rope. And the linear acceleration of the rope is the same as the acceleration of the mass that's attached to it by the rope. Because the rate at which the speed of this rope is spinning around is also the rate at which it spins such that this thing falls. So this is the key thing here, is that A is equal to 2T over M, which, oh man, look at this. I can now plug this into here. Tin. Dude, I swear it's antimony. Could you solve for T, plug that in for the sum of forces, and then solve for A because we don't know FT? Wait one second. Could you solve for T? Yes. And that's actually exactly what you're going to do here, right? So here, it's just like the order in which you do things, right? So this is t is equal to m, and then that's going to be g minus a, right? And then if you plug that into here, right? Now you're going to get that a is equal to 2 little m g minus a over big M. But this is a mess. Because do you see how I have a in both sides here? Yeah, this is not good. We don't want this. Because that's hard to like substitute in. Can you go over 22 on the power? And the yeah. Well, now she wants it. Okay, so yeah. What I would do, because I know eventually I want A, right? I'm gonna plug this in for here, and then I'm just gonna solve for A. So I would plug this into here, Sancheezy, such that I get mg minus 2t over m is equal to little m a, right? So then, let's see how this works. So g minus 2t little m big M is equal to A? Is that right? I thought I remember it being different. Yeah, sorry. Yeah, that's what I did wrong. My bad. Sorry, I'm getting twisted sideways here because we're 2 hours in. This goes into here. Sorry. I was like, that's wrong. Mg minus t is equal to m over big M, little m over big M, 2t. Yeah, thank you, Sancheezy. You've been hitting the gym, brother? I did hit the gym this morning. Yeah, I did. Oh, wait. No, but I want acceleration. No. I don't want to solve for tension. Okay. Let me solve for t here instead. T is equal to a over 2m. That's what I want. And then I want to plug this into here. mg minus a over 2 big M is equal to little ma. Cool. Are we doing that right so far? No. I'm doing it backwards as well. Oh, this question will be the end of me. Big MA over 2. Exactly. You're right. Yeah, sorry, you are right. Yeah. Okay, here we go. mg minus big MA over 2 is equal to little ma. Move it over, right? mg is equal to big M over 2a plus little ma. So now little mg is equal to a, and then this is big M over 2 plus little m. So now a is equal to little mg over big M over 2 plus little m. Okay, cool. This, I think, makes sense to me. Because, yeah, if big M is big, then the acceleration is 0. If big M is 0, then you get mg over m, so you get acceleration is just equal to g. Bro needs a nap. I do need a nap. I'm getting tired. Sorry. Yeah, well, we're going on 2 hours at this point. Yeah. Okay. This is it. Solve for a. Delta y is equal to 1/2 a. And then this is 3 squared. And then you're done. Okay? I apologize for all the math mistakes, algebraic mistakes I was making here. I'm getting a little tired. Sir, you only teach U.S. students, or I teach students everywhere, dude. I mean, my job is teaching students at UCLA, but my nonprofit, we teach students wherever, dude. Yeah. Okay. Cool. Does that make sense for everyone? Yeah. There is an aluminum strontium alloy. Dude, I swear it was antimony, dude. Antimony is a thing, dude. Sorry. Antimony is SB. Yes. Okay, I remember. It's not aluminum. It's just... It's one of those things where the periodic table name for it makes no sense. Like, AG is silver. I know AU is gold because that's Latin, right? Like, gold is aurum, like AAU or something. I do need to hydrate, thank you. Oh, wait, Agrium? Agrium is silver? JP says, what do you teach at UCLA? I teach mechanics for pre-meds. Sorry, life science majors. Basically pre-meds. Nicholas says, can you help with physics 5B and 5C when we're taking those next year? Yeah, so this stream will always be here as long as I still have the ability to, like, pay my rent. So, yes, you are more than welcome to come by. And I do these streams every week. I do them, like, 3 times a week. And you can ask whatever you want with any of your other questions. I don't care if it's, like, chemistry or, like, stats or, like, you know, this is the whole point of our nonprofit here is just to help people for free, so. A lot of the periodic table is Latin, yeah. But yeah, so, yeah, save the stream, save the whatever, the YouTube, like, subscribe, and you'll get notifications when we go on. And you can ask whatever. But, alright, I think Liz and Carly were asking about, where is it? This one right here. She says, yes, do this one. Okay, fine. Isn't silver AG due to argent? Yeah, JP, apparently it comes from agrium, which is the Latin word for silver. I know aurum is the Latin word for gold. But Carly says, yes, let's do this question. Okay, here we go. Okay. A hollow sphere of mass 0.942 kilograms, and this rolls without slipping at a speed of this towards an inclined plane, which is tilted at theta equals that. The ball rolls up the inclined plane without slipping. How far does it go up the plane before it comes to a stop? Know that all variables must be needed. Okay. I'm going to do everything. Sorry. I'm going to do everything in terms of variables here because I think you guys get different numbers for things. Yeah, well, Latin, yeah, they're all French, Italian, they're all Latin-based. Same origin, same. Okay, so let's call this situation 1. Let's call this situation 2, all right? So in situation 1, let's add up all the energies. So you have mu g is equal to 0, because it's at height equals 0, right? You have kinetic energy due to it moving, and so that's going to be equal to 1/2 mv squared. Let's call it mv1 squared. And then you also have rotational kinetic energy, because it is rolling, right? And that's going to be equal to 1/2 I omega squared. I, in this case, is a sphere, which is 2/3 mr squared. So this is the same thing as 1/2 times 2/3 mr squared. And then omega, I like to write omega is equal to v over r. So omega squared is equal to v squared over r squared. So we get rid of this. V squared, r squared. So now r squareds cancel. Right? We don't need these anymore. And so that's just gonna give me what is that? That's just 1/3 mv squared. Once we do all the simplification. You're very welcome, Daniela. Yeah, of course. Tungsten is W for Wolfram. Stop. Daddy Steve isn't that, he's not that popular, man. He doesn't get to name things on the periodic table. Okay. All right, let's look at situation 2. So in situation 2, okay, it's rolled up, okay? So mu g is not going to be equal to 0. That's going to be equal to mgh. Kinetic energy, however, will be equal to 0 because it's not moving anymore when it gets to the highest height. Also, rotational kinetic energy must also be equal to 0. Okay. Here's the key thing, though. If this was friction... So notice how they say the inclined plane without slipping. That means that when it stops moving, it stops rotating. If this was frictionless, okay, then this thing would still have the same rotational energy it had here. Imagine taking, like, something that's spinning, and then this is like ice, and, like, whatever, you push it up, it would still keep spinning. So if this was frictionless, this rotational energy would not be 0. This rotational energy would be the same rotational energy it started with, because it would be spinning the same amount. You need friction to lock translational motion and rotational motion together. If there is friction and things are not slipping, then every time something moves linearly, it also rotates. And when it stops moving, it stops rotating. But if things are slipping and there's no friction, now they're not linked. So you can have something move and not spin. You can also have something spin and not move. Just key little important thing there. Okay. But we said that there's no slipping. So these are going to be the same, which means they're 0. And so they want to know how far does it go up the plane. So they want to know this. The non-slip condition. Everything's non-slip. Spherical cows, dude. So, curious. Here, no way IRL, there is not friction there, though. That buff is pretty harsh. It is a pretty... I mean, what if it was made out of, like, I don't know, graphite? Like, powder? Okay. If this... So if we look at this as like a triangle, right? If this is the height here, h, and then this is L, and this is the angle theta, they're related by sine. So I know that sine of theta is equal to h over L, or L sine theta is equal to h. So in this case, this is mg L sine theta. Okay? So adding all up these total energies, you just get mgl sine theta. I realize I used different m's here. These should all be lowercase m's. I apologize. Yeah, this should not be an uppercase m, just lowercase. Okay, so now you just set these energies equal to each other. Notice that the m's are going to cancel. I don't care about the mass. And I'm going to get that L is equal to 1/3 v squared over g sine theta. Oh, no, I fucked up. One sec. I fucked up here. Sorry. It's not just equal to this. It's equal to this plus this. So the total energy here, right? That's equal to Ke plus Kr, which is 1/2 mv squared plus 1/3 mv squared. This ends up being 5/6 mv squared. If we remember how to add a half and a third, right? Common denominators. This is 3/6 plus 2/6. Exactly. You use L sine theta because you don't know h. Yeah, for sure. Sorry, let me get rid of this. This was wrong. Also, because that's what they're asking. They're asking you to solve for L, right? So you know you need L in there somewhere. So if you have h, you know h relates to L by that angle. Great question, Liz. I was thinking, yes, good job, guys.
Yes! Hell yeah!
Good job. They got the smart brains running today, for sure. Okay, this is this. Yes. Cool. I think we're good. So now we have that L is equal to, I want to say this is 5/6 v squared over g sine theta. Yeah. That'll be your final answer. Which, let's see. I'm pretty sure that's what they have on Kudu. Yeah? Yeah, look here. It says, 5/6 v squared over g sine theta. Nice. Okay, cool. Yes, we did it. Good job. Alright, you just donated. Thanks, Flug. $5. Nice. Okay, stop that. Appreciate that, Flug. I need our PayPal link to work. Dude, fuck the state of California. They take so long to process paperwork. Because we had to renew our nonprofit status, and because they're lagging, PayPal like revoked my like giving fund thing. And I'm like, bro, it's in process. They're like, well, it needs to show complete. I'm like, man, do you understand how long it takes things in California to get processed? Anyways, but I appreciate that, Fluke. Thanks, man. No, you're cool, dude. Yeah. No, the ruckus is great. No, the ruckus was, I already created the ruckus because we finished a question here. You just happened to come in at just the right time. I'm a fan of real education. You're a fan of actual education, you mean? Thanks, Fluke. Yeah, we're helping out some students. They have a physics final tomorrow, so I'm going over some physics questions for them. Hello from Iran. 3 a.m. Wow. That's cool, man. Iran. I have a lot of Persian friends, you know? I wish I would be able to... I hope in my lifetime things like chill out at some point that I can go visit Iran. Sounds like a cool place. Evenion says, what's your opinion on quaternions? Yeah, that's like quantum gravity stuff. So, I have one of my best friends, I was best man for his wedding, is a quantum gravity researcher. He's a quantum gravity physicist. He's a really cool guy, actually. Let me see. David Chester. You can see him on YouTube. Here we go. But he knows about quaternions and stuff. What are these ads? I don't need ads. Chill. Anyways. So, here, I'll link you to him.
What did you get your degree or whatever in?
So I studied theoretical.
So this guy, he was in grad school with me. We were both in the same year at UCLA, and he does quantum gravity research, and so he knows about like quaternions, like E8, like all the crazy stuff. Octonians, I think, dude, there's so much stuff going on there, but he's a really cool guy. If you want, I can get you in contact with him. He does cool stuff. He's been on our, so we do podcasts sometimes. I don't know if you noticed. If you go to our YouTube channel, Octonians are harder, not even associative. Yeah, see, there you go. Where's my videos? Yeah. So I've had him as a guest on I do like a podcast sometimes on Fridays. Yes. And so we had a 3.5 hour podcast with him once. And
oh my gosh.
So here you go. Do you see this? Like brains? Like, what are these things, dude? 11 brain, 3 brain, 19 brain. I have like no clue what this stuff is, but he was talking about it. Like, yeah, warp drives and stuff. Yeah. Anyways, he's a cool guy. One of my best friends in LA. Yeah. Okay, cool. Any other questions from the students? Any other stuff you want me to go through before I take a chill dinner or something? I don't know. Let me see. Personally, getting into a lot of complex linear algebra, cool. Yeah, dude. Evenion, if we have a whole community of really awesome, like high-level math streamer people on Twitch. So let me get all the names for you. There you go. Here's all the names for them. If you want to follow them, they're really cool. And some of them have like self-study groups they go through. Chat, I'm scared for the final. Don't be scared for the final. You'll be fine. Wait, why can't I send this? Oh. Alright, whatever. I'm gonna send Zach and Penn Center at least. Yeah, there you go. Go check out all those guys. Those are cool. Those are some of our math streamer friends. If you follow them on Twitch, they do streams where they just talk about math, and I'm sure they would love to just go into like some high level stuff. Hassan is in the middle of everything. If you want to go check his stream, what's he doing? Hassan who? This guy? Hassan Abi? Is he in LA? Oh, nice, dude. Oh, he's in the middle of the protests. Where's he at? Let me see the cross street. Alma and... One sec. Let me go through my chat real quick. That's cool that Austin is doing that. Sunday protest day. All right. Let me see. Which question do you think is the hardest one you've assigned us? Hardest question. I think this one, not this one, sorry. This one was fairly difficult, for sure. This one was a very difficult question. I think it was difficult because you had to do kinematics, and then you had to do dynamics, and then you had to do rotation as well. Gold, did you get 22.9 for FRQ Part A? I think I did. I'll send you the solutions Fembox as well later. Whatever you feel is vital. For the final practice, what was the hardest? Let's see. Hardest question. This was all like kind of easy, honestly. This is the problem, dude. I think the practice final is really easy, but I understand it sometimes isn't. Maybe the bullet with the disc, because I that's not something we really covered in class. R cross P. We didn't really cover that. Things that just have a perpendicular distance and velocity have angular momentum. But if you think about it as like right there, then it works. That's fine. Don't be scared. There's no curve. Yeah, so, okay. Yeah, there isn't a curve. But I kind of artificially impose a curve because if everyone gets like a certain question wrong, I end up just throwing the question out. So that's kind of like a curve per se. Not saying don't go get all the questions wrong. I'm not going to throw out all the questions. But if there's something that like everyone is like not understanding and getting confused and it would cause the class average of the exam to go up, I usually toss the question because that's on me. Like if most of the class doesn't get it right, it doesn't mean that you guys are dumb. It means that I A, didn't teach it, or B, I designed a shitty question. So yeah, try your best. You'll be fine with her. 35% is such a major chunk. It is, but think about it like consistency wise. So if you've been doing well, right, in your midterms, if you've been doing well, you know, on the homework, you've been showing up to office hours, like this 35% is, I agree that it's a big chunk, but it's your performance on it will be kind of how you've been doing in the class the whole time. It's not a new 35%, right? It's 35% and you've already done, I would say, most of it because a lot of it covers what you saw in exam 1, 2, and 3 or anything you did in the homeworks. So it's not 35% like out of the blue. If you want to talk about like ridiculous classes, dude, my first year of grad school, I failed quantum because our grade distribution there was 10% homework, 90% final exam. The final exam was 90% of your grade. And first of all, failing in grad school is like getting a B-. It's really whack. But I ended up getting a B- in that class because, yeah, the final was 90%. And I remember just having a panic attack because I'm sitting there looking at what to me looks like gibberish. It's quantum mechanics. And I'm realizing, oh man, oh fuck, I'm about to like totally fail this class. I ended up like getting out of my seat and going for a walk around campus around the building for like 5 minutes just to like chill myself out, and then I came back, and then I didn't absolutely fail, but I got a B-. So summer break, gonna check on those guys. Yeah, for sure, Evanon. Yeah, good. Yeah, good luck with your last school week. Then comes the grind. And I mean, we'll be streaming over the summer. If you want help with any, if you want to like self-explore stuff, we're happy to help you out. Knowing complex analysis in high school feels really good. Yeah, well, complex. Yeah, that's like an undergrad course. How much content from each midterm would be on the final, like percentage-wise? I say it's like 50% exam 1, 2, 3, and then 50% what we've been doing in the last 2 weeks. But that's kind of hard to say because I don't know. Everything is needed, right? So, for instance, in this question, right? Yes, conservation of energy, which is what we learned recently in the last 2 weeks, but also you have rotational stuff, which we learned in exam 3. Also, you have kinematics, which is like from exam 1. So, physics, it isn't like history where it's, you know, oh, how much is going to be on the Civil War? How much is going to be on World War II? How much do I have to know about Vietnam? Everything in physics like is used for the next thing. So it's hard to like segment it, really. But it will be mainly focused on midterm 3. Would you teach any other physics classes? Do you get to pick? I'm teaching physics 1B over the summer. It's an online class, which I guess I'm going to have to do through here. And then I was slated to teach in the fall. That's kind of up in the air. I mean, the official word is no, but they told me that they might have an opening. So I don't know. We'll see. It's again, as I've already said before, there's a lot of weird budget things going on. Trump is threatening to cancel UC funding. I don't know. I like teaching. I will still be here. I will always be here live streaming. I will always be here to help students out with math and science. I enjoy teaching at the university level. It is very fun.
But whether that's like feasible economically from their point of view is yet to be determined. Maybe we could get someone to like donate a bunch of money to the university. But actually, don't do that. I don't agree with what they do with their money. But how are you in Orgo? I can try to figure out organic chemistry. I took it. I don't really teach it.
I can try to help with organic chemistry, but I will warn, I'm not the best at it. Regular chem, like Gen Chem, like Chem 1 and 2, amazing. I can tutor Chem 1 and 2 like for days. I love chemistry. Praying that somehow you teach 5B in the fall. Okay, I appreciate that, prayers. I came back and heard politics. Your voice changer turned on. Yeah, they can trigger it in Twitch from like if they watch the stream for enough time. They get points, and then with the points, they can like buy like modifications to the stream. It's fun. Yeah. Okay. Any other questions before I sign off? You guys are gonna do great. Like, don't worry. Just keep doing what you've been doing. I'm not gonna throw any curveballs on the final. It's everything on the final, with the exception of like one thing, is something that you verbatim have seen on either a homework, a clicker, a practice quiz, or something else. Like, nothing should be out of the blue, like, strange. Can I go F for Q1? Yeah, I can do it. Yeah, let's just do it. Fuck it. Or, yeah, discussion. Like, Morgan's discussions are good. Morgan's a fucking saint. You guys got really lucky with her as a TA. But I like the questions she does. Some of them are a little bit harder, and I would say not time appropriate for like a midterm, but they could be for a final. No, I don't think I did this one. I feel like I'm going to rely on partial credits so bad. Yeah, luckily I give out a lot of partial credit. Oh, one second, I got to reload this. Most professors would just give you zeros. Yeah, if people ask, like, you know, I'm worried he doesn't curve the exam, I kind of curve the exam through partial credit. I'm very generous with the partial credit. Yeah. Okay. What is the speed of the hoop when it reaches the bottom of the ramp? So this is situation 1. Let's do situation 2 is here. Right when the hoop is moving. It has like some velocity. And then eventually we'll get to like a situation 3. Which is when it's hit the ground. Okay. So in situation 1, we have potential energy. We're just going to write out what all the energies are. So this is going to be, if this distance is L, and we don't like those professors. Yeah, I get it. Sorry, look at a different color for this. This is L sine theta. L sine theta is this. Right? Because if this is L and this is theta, then L sine theta is this. Okay? So, potential energy is going to be mg. Ooh, get different, same thickness. No, too thick. There you go. Mg, and then this is going to be h plus L sine theta. And then I think it starts at rest. So kinetic energy is equal to 0 and rotational kinetic energy is equal to 0. Cool. Situation 2. So now we have mu g is just equal to mgh. Kinetic energy is equal to 1/2 mv squared. Rotational energy is equal to 1/2 I omega squared, which is equal to 1/2 mr squared. And then this is v squared over r squared. Again, just always make the substitution that omega equals v over r. Cool. So that just is equal to 1/2 mv squared. Sorry, I need to use the same. It's the same v, the same m. JR, you can during the week. This is a special stream I'm doing for my my physics students. But during the week, yeah, you can submit anything. I think as long as it's like math or science. I mean, some people submit like English things to me, and I'm just like, I don't know, ChatGPT. Okay. Also because English is like subjective. It's so hard to tutor. I mean, there are some basics you can teach people for like writing and stuff, but a lot of times it's really just following whatever rubric your teacher wants you to do. Where to send? Not today. During the week. Come back during the week. Come back tomorrow. Tomorrow I'll do it. Okay. Okay, so cool thing here. So I set the total energy here. Total energy here. Yeah, this is first year physics within reason. Like, so I can do up to like maybe second year graduate physics. Don't start giving me like field theory shit or something. Yeah, first year college. Okay, so total energy here is just this. Oh, here's a cool thing actually. So we have mgh here and mgh here. This whole thing goes away. This goes away. This goes away. The m's are also going to cancel. And so you're going to get that the velocity is equal to the square root of GL sine theta, which in this case was 9.8. 9.8. Did I say what the length was? 4 meters. Cool. And then what do we say the angle was? Oh, sine of 30 degrees. Oh, that's a half. Nice. So, square root of 19.6. Yeah, nice, dude. Thanks for the sub. So that's actually a little bit less than what. Okay, let me see. Let me make sure I have the correct thing from our answer. It was this lecture. Yes. Okay. It was 4.43 meters per second. Fembox, I'll send this to you as well. Oh, okay. Can you find the difference between M and M? Yes, sorry. So usually, so M just refers to mass. Because they wrote a capital M here, I should have written a capital M here. You're correct. I'm just pretending this is like little m, okay? In reality, there's only one mass we're dealing with, so any like M, whether it's uppercase or lowercase, is the same M. In situations such as this question, okay? This question has a capital M for the disk and a lowercase m for the block, because there are two different masses. Here is where lowercase and uppercase m matters. Exactly. Moonchild is correct. Completely correct. Yes. So here, I agree. I should be more consistent with this. But yeah. Oh, no, this is not first year high school. No way. Okay, so 19.6. So square root of 19.6. Is it, yeah, 4.43 meters per second. Yeah, you're good, Nicola. Okay, cool. Alright, that's question 1. So, step 2 is how far horizontally from the base of the table does the hoop hit the floor? Okay. So now this is a kinematics question. Here, let me pull it up. Sorry. Can I... This zoom doesn't go any bigger? Why don't they use subscripts? We could use subscripts. Okay. Nope, fuck that up. Okay. So how far horizontally? So they want to know this. This like delta x, okay? And we know that this delta x is going to equal to Vx times t. Another way we could have written this is, I could have written this as like, no, we'll just leave it as v. And because this is all Vx. Right? So once this thing rolls down and gets to here, all of its velocity is in the x direction. And then this thing is going to go like this and eventually fall. Hit the ground. Okay. The annoying math conjecture, maybe. Wow, what's up, Reki? Oh, you plugged in G over R instead of G over 4. Ah, yeah, all good, Fembox. Okay, and so the key thing is the amount of time it takes for this thing, for this whatever hoop disc to move left to right is the same amount of time it takes for it to start up here and then to fall down to the ground. So I need to solve for the amount of time it takes for this thing to drop this way. And the way to do that is to use our kinematics equation here, which is that y equals y naught plus v naught yt, and then this is going to be minus 4.9 t squared, because this is 1/2 times g for acceleration. And then y minus y naught, that's going to be negative h, right? So the amount of distance it travels in y is negative h, because y final is 0, y initial is h. So you get negative h is equal to, the initial velocity in the y direction is 0, because this thing is only moving left-right when it's on the table. So this is 0, and then you have minus 4.9 t squared, okay? So then h we know is 4. So I have 4 over 4.9 is equal to t squared. And then I'll square root that. And so I get that t is equal to 0.9 seconds. It's exactly 2 square root of 2 meters. Yeah, is it? Yeah, you know, that comes from the sign there. Yeah. Okay, so then this is going to be 4.43 meters per second times the 0.9 seconds. Inaki with the sauce. I'm just doing physics today. I'll do math during the week tomorrow. If you want to come by tomorrow, make sure you subscribe, turn on notifications, and you can ask that question during the stream tomorrow. Oh, wow. Do I get exactly 4 meters? No way. Really? That's actually kind of cool. Where was it? Wait. Ooh, I got 0.64. Okay, something's wrong here. Sorry. Oopsies. One sec. We did something wrong. Yeah, thank you. Yeah, no, I screwed that up. Yeah, sorry. Yeah, I screwed it up. So wait, I did 8. Oh, H is 2. H is not 4. Where did I get 4 from? Oh, L is 4. Sorry. Okay. H is 2. Okay, sorry. Yeah, so sorry, that's why this answer is wrong. I'm getting tired. I'm gonna start making more and more mistakes as I get tired. Okay, 2 divided by 4.9 equals that to the 0.5 power. Good. T is equal to 0.64. Okay. So here. Okay. So we do this times 4 point. What is it? Fucking. There it is. No. Where's that number? There it is. Cool. And that gets us 2.8 meters. Nice. Okay. Mistakes are alright. Keep up the amazing work. Yeah, I appreciate it. Yeah. I think it's always good to show to students that, like, everybody makes mistakes. Especially, like, dumb little, like, data entry mistakes. Happens all the time. And I don't mark off too much on their exams. If they make, like, slight math errors, they see, like, I say small math mistake, and I give them just, like, -2. Because I don't care about the math mistakes. What I care about is, like, conceptually, do you understand how to do the question? Data entry is something that eventually just AI will completely replace. Just making sure we have the right numbers. But the strategy and, like, how to solve it, that's where the human needs to do things. I know AI these days can solve this as well, but I digress. Okay, this is cool. So, step 3. This is the one that I think is probably scared students a little bit. Okay. But it said, all right, here we go. So, if... Yes, you can leave everything as symbols. Yeah, 100%. I try to encourage my students to use variables. They're scared of them sometimes. But yeah, I do as well. I do. Okay, so it says, if you replace the hoop with a solid sphere of I is equal to 2/5 mr squared, would the sphere hit the floor further away or closer than where the hoop hit the floor? Okay, so if instead of a hoop, which had I was equal to mr squared, we replace it with a sphere with I is equal to 2/5 mr squared, which one, like, falls further? Right? And then you have to, like, kind of explain with, like, some physics concepts here. Get rid of this. Yes. So that is a great idea here, Fembox. So yeah, I like to say that, like, I, or like inertia, is resistance to changing rotation. Okay? So higher I means more energy lost to rotating. So here's a key thing, is that, like, whether it's a hoop or whether it's a sphere, in situation 1, they start with the same total energy. Because the total energy here is just mgh. Okay? Here, right? E total is just equal to mg, and it was h plus L sine theta, right? And that's the same thing here, okay? Regardless of what shape it is, it's the same. All right? Now, once the thing falls down the ramp, okay, now it's going to have kinetic energy and rotational kinetic energy. Sorry, linear kinetic energy and rotational kinetic energy. If you have a higher I, then more of the energy here had to go into rotation. So I like to think of it this way. So let's do this. So you have UG, you have KE, you have KR, right? And then you have the same amount right here starting at the beginning. And then once the thing, pretend MGH is, pretend this is like height equals 0. Just humor me. Let's pretend it has 0 potential energy here. What happens is, as this comes down, it's going to transfer energy over into kinetic, linear kinetic, and to rotational kinetic. Now, if you have a higher I, okay, then more of this energy needs to go into rotational. And if more of your potential energy is getting put into rotational, less of it gets to be put into linear or translational kinetic energy. And translational kinetic energy, the linear kinetic energy here, that's what determines the velocity that it leaves here, and that is what determines how far away from the edge it hits. So higher I means more energy lost to rotating, which means less E for linear, or like just moving. So lower V, so lower distance that it travels. Yeah, I wish all professors thought the way you do, because then maybe people wouldn't dread the physics series. Yeah, I've heard, again, and I peruse Reddit and stuff sometimes. The UCLA physics department does not have a very good reputation, apparently. Like I've heard people say that it's like one of the worst for teaching. I kind of get it, because again, a lot of the professors, so professors have 3 requirements. So they have to do research. They have to, it's called like service to the university. So that's like being on some sort of like board or like Senate or like some committee, like whatever, like, some admin bullshit. And then there's also teaching. And they're required to teach, I think it's 3 quarters a year. So sometimes they'll do 2 sections 1 quarter and then 1 section another quarter, or they'll do 1 across the 3 quarters. But most of the time, professors are hired not to teach. They're being hired because they do great research. Great research brings in grant money, and then grant money, the university takes like half of it to fund all their other stuff. It's called overhead. And there's a lot of politics in this as well, because if you watch the news, you know that Trump has like completely shut down all NSF funding and DOE funding. And I think it's expected for the budget next year. I went to a town hall for this. Grant funding is going down to 67% of what it used to be for most physics research. So there's going to be some problems. But when the university has extra money, I believe what they do is, instead of having professors who don't want to teach the physics classes, they go out and they hire people who actually want to teach physics to teach the physics classes. Because it's like a luxury for them. So, yeah, it is pretty awful, Hamiltonian dynamics. Yeah, it's not great. Also, there's some interesting things where, so when professors write grants to the government, being like, hey, I need some money to study this thing, you're allowed to specify what percentage of that money you get is going to go to what's called quote unquote overhead, which is money that the university takes to, they say, to keep the lights on, to, pay for the electricity. Also, I think it helps fund like grad students and stuff. So that used to be around, I think, 30 or 40%. Don't quote me on that. But I know Trump just put out an executive order a couple months ago where that has now been limited to like 10%, 10 or 15%. So now the cap on how much money you're allowed to go to like whatever associated costs, it's called overhead costs, is like much lower, which I kind of agree with, because I think it's really weird that the university takes so much money from a grant and just indiscretionally like spends it on things. But also, I understand the university needs cash to, again, pay for janitors, pay for electricity. I understand it needs to do that. I just hope it's actually paying for that. Which now professors, when they write grant money, when they write grants for money, they have to specifically say this amount is now also needed for the electricity. This amount is needed for my grad student. So it's an added burden, but it's another way that, like, dude, everything in academia is topsy-fucking-turvy right now. I'm just trying to teach physics. I just want to teach physics, please. Is that hard? Okay. Anyways, enough ranting. Let me see. What did someone say? Could you go over 4 and 5 on the practice kudu? I like using up and down arrows in formulas to indicate whether a variable increase or decrease. That's a great way to do it. Yeah, I like that. That's a really cool way. Yeah, up and down arrows. Yeah, no, that's good. I mean, that's kind of what I would have said with help with AAP and PLF is going away. What is PL? I don't know what AAP and PLF is. Is that like student learners? Yeah, they showed me some cute graph at the town hall where it's like TA salary is going up, which it should, because like TAs should be being paid more. Like life's getting more expensive. But then they showed me like budget for teaching, and it's going way down. So their solution is to cut TAs. They say they're 100% committed to still supporting every graduate student, but I'm confused how they're going to do that, because there's like a big gap. But they also only admitted 11 graduate students. Sorry, 15. 11 domestic, 4 international. They only admitted 15 graduate students to next year's incoming physics class. My year was like 40. And I think the year before this was like 27. But they've drastically cut it. It's now only 15 graduate students. Probably 11 because the 4 international are about to get like screwed. But yeah, there's a lot going on, man. Yeah. Oh, peer learning facilitators that help students with STEM. Yeah, they're tightening a lot of budget stuff. UCLA is getting really particular now about spending of any sorts. Like if you want to like host a pizza party or something, you now need to get permission for it. Like there's a lot more paperwork apparently that's being required. Which, yeah, if you're in debt and running out of money, yeah, you'd start like tightening the budget, I guess, a little bit. But Josh, the other professor, he has an interesting graph showing that salaries for teaching has basically stayed constant, but salaries for administration and like Senate and like whatever other positions there are, it just keeps going up. And I'm like, well, that's a problem, because we're a university, we're supposed to be teaching, like not paying for, I don't know, whatever weird administration positions to like do stuff. Anyways, priorities. Okay, let me do the kudu question. What do you want? You want the harder question, 4 and 5? Let's go do it. But yeah, that's unfortunate. I don't know. We're in some weird times for sure. My number one advice is, just keep focusing on yourself. Don't let it affect you too much. If you keep doing well and get good grades and get a degree, something nice should be there at the end, right? Oh, where's the harder clicker questions? Wait, no, here they are. Do the students have to pay for kudu? Yeah, this is their textbook. So, but they only pay $20 or $25. It's cheap. Most textbooks are like $200 or $300. So, this is like a cost-effective textbook for them. Cheaper, I guess. Okay, 4. Yeah, man, this one is a doozy.
Nice.
Control the controllables. Yeah, exactly. Thanks for the follow. Yoyoise. Why Yoisi? Okay. I'm going to do this all in terms of variables. Construction worker is standing at the top of a rooftop. It rolls down the roof, which has an angle. The bottom edge of the roof is 3 meters above the ground. Okay. So, distance from here to here. This is 3 meters. And then the guy is 1.8 meters tall. $1,200 engineering students. That makes sense for a bachelor's. Yeah, when I was talking about the 15 students, that's graduate school. Which, again, they're probably cutting it down because if they admitted more graduate students, they would have to create more TA positions, and they just don't have the money for it right now. Because that's how TAs like pay for their tuition, and how they pay for, I know, life is they TA. Nice practice exam. I feel like you've definitely focused on conservation of energy. Cool. See students, some outside person who's not even in your class agrees that it's mainly conservation of energy. Yeah, dude, some of the OChem textbooks are like redonkulous expensive, dude. And now they've made it so you can't get used books because they force you to buy like an online code to do your homework or something. It's such a scam, dude. I hate it. Anyways, okay. This has some velocity v, guys, right? So I'm gonna break that up into Vx, which is equal to v cosine theta. And also I'm gonna break that up into Vy, which is equal to v sine theta. I'm gonna say this is negative v sine theta because it's pointing down. Yeah, the textbook industrial complex. Dude, it's the worst. Okay, so I want to know the distance that they need to be for this to like to just barely hit their head. Okay, so we're gonna look at stuff in the x direction, right? So I'm gonna call this x equals 0. So I'm gonna say 0. Sorry, I'm gonna say, so delta x. Let's just, yeah, whatever. Delta x is equal to v naught x times t plus 1/2 at squared. There is no acceleration in the x direction, so this is gone. And then v naught x is equal to v cosine theta, okay? So delta x is equal to v cosine theta times t, okay? So now I just have to solve for t, right? If I solve for t, then I get the distance. Well, to solve for t, I need to look in the y direction what happens. Well, this thing starts up at 3 meters. So I can say 3 meters. Well, no. So and I want it to end here at 1.8, right? So the ball is here, and then the ball is here. So I'm going to say, okay, 1.8 is my final y position. 3 is my initial y position. And then I can say minus v sine theta times t, right? Because that's the velocity in the y direction. And then we're going to say minus 4.9 t squared. So this was our kinematics equations for something in free fall in the y direction. One day all education will be free. Yeah, hopefully. Okay. So I remember why this question is tricky. This is a quadratic to solve for t. So this is 4.9 t squared plus v sine theta times t minus 1.2 is equal to 0. You need to use a quadratic formula here to solve for t. And then once you have that, you plug that into here. I don't think I'm going to force you to do quadratic stuff on the final. Yeah. So if I were to give you a question similar to this, I wouldn't make you use the quadratic formula. I don't think I'm going to make you do that. But this is how you would do it. You would plug in, first of all, you need numbers for here and here. And then you need to remember the quadratic formula to solve for t. And then you can plug it into here. And that'll get you delta x. Does that make sense? Who asked this one? Owen. Yeah, Owen. Does the process make sense? I'm going to save my energy for plugging in the numbers, but... You already submitted the answer. Okay. Subject in school? Orchestra? No, I hate orchestra, actually. I like playing the cello, but yeah, orchestra actually kind of sucks if you're a cellist. Honestly, I really liked computer science. I'm a big fan of computer science. It was cool. I ended up doing physics. Oh, we lost the thing. Sorry. I ended up doing physics because I knew I wanted to do one of the sciences in college. And physics to me was the most interesting in terms of I like the freedom in that you don't have to just use one equation to solve things. You can do there are multiple ways to do it. It's kind of like one of the more creative sciences. I know that's kind of a weird thing to say, but you get more freedom and liberty in how you solve questions, which is creative, I think. Okay, yeah, so here. All right. So we're going to consider everything here at T3, all right? Or is it everything, not at T3, sorry, at this point, okay? So here, well then let's consider this, right? So this has mg pointing down, has T3 pointing up. So from sum of forces here, you get that T3 is equal to mg. And then so here, you're going to have T3 pulling down. You're going to have T2 pulling to the right, but that's going to have components, right? So you're going to have T2x, which is T2 sine of 50 degrees. Sorry, let me just write this on the side here. So T2x is equal to T2 sine of 50 degrees, because this is the opposite side, Owen, to this angle. And then T2y is going to equal to T2 cosine of 50 degrees. Now, for T1 here, it's a little bit different. So now I have that T2x, which is this, right? That's the amount of T1 that's pulling it to the left. That's equal to negative T1 cosine of 60 degrees. See how this is weird, right? Ooh, cosine was used for y here, but cosine was used for x here. That's because the angles they gave us were different angles. This is the angle with the vertical. This is the angle with the horizontal. And this is why don't ever memorize that like, oh, y is sine, x is cosine. You have to look at the triangle and figure out, oh, which side with which angle. This is statics, yeah. Statics is your favorite? Okay, statics is cool. Yeah, you only have to remember, yeah, it's like sum of forces, sum of torque. What's the third one, you think? I think it's like sum of forces, sum of torque, right? That's basically it for statics. Okay, then T1, sorry, this was T1x, not T2x. Sorry, man. T1x is negative T1 cosine 60 degrees. T1y is T1 sine of 60 degrees. Okay. So now you just do sum of forces in the x direction. And so you get T2 sine of 50 degrees minus T1 cosine of 60 degrees. And this has to equal 0. And then in the y direction, you have T2 cosine of 50 degrees minus T1 sine of 60 degrees minus mg, right? Because T3 pulls down, but T3 is the same as mg, because that T3 is what keeps m up. Okay, so then this is sum of forces in the y direction. And then we say the tension that the rope breaks T1 is 99.7 newtons. Okay, so that's cool. And what do they want? What was this question even asking for? Sorry. Oh, what's the mass? This feels like high school physics. It is. I mean, it's college physics, but it's intro college. So intro college is like high school, just like but there's a little bit more depth to it. This is like AP Physics 1, which is a high school course. Okay, so they want to solve for m. Okay, so from here, right? Okay, cool. So mg is equal to all this, right? If I move this over. And then I know what T1 is. So from this, I can say that T2 is equal to T1 cosine of 60 degrees. So all I do is I move this over, and then I divide by this, and I say divide by sine of 50 degrees. How long does it take for the recorded stream to upload to the channel? It'll be instantaneous. The second the stream ends, it'll be there. Which, I'll make this the last question I'm doing, because I do need to go eat dinner. And we've been going for almost 3 hours. Okay, so this becomes... So this comes into here. So you get T1 cosine 60 degrees, cosine 50 degrees, all over the sine of 50 degrees, minus T1 sine of 60 degrees. Cosine of 50 over sine of 50 is cotangent. Yeah, I get that. All right, so this is T1, and then this is cosine 60 degrees, cotangent 50 degrees, minus sine of 60 degrees. And then you just divide by m. No, sorry, divide by g. We want m. So there you go. I got confused, and chat got it wrong 8 times. Yeah, dude. So this is the issue. Like, ChatGPT will mess this up. Oh, wrong thing. ChatGPT will mess this one up because it can't. It sees the angles, and it doesn't know that one's from the vertical and one's from the horizontal. If you want to see that, like, watch this. Watch this. I'll throw this in two different. It depends which ChatGPT you throw this in. So here, let's go to regular 4.0. I'm gonna say solve this. Who wants to solve today? Okay, and then I'm gonna throw another ChatGPT in, but I'm gonna throw 04 mini high on it. Okay, so let's see. Let's see if this gets it right. So this gets 14.9 kilograms. Was that the right answer? Yeah, see? Okay, watch. You want to see why this messes up? When it does the angles here, it assumes that these angles are like both horizontal or both vertical. The 60 is with the horizontal, the 50 is with the vertical. So that's why it messes up here. So look, in the horizontal direction, T1 cosine 60 is correct, but T2 cosine of 50 is wrong. T2 cosine of 50, that's this side. That's a y component. So this is why ChatGPT gets the wrong thing here when you use 4.0. If you use 04 mini high, which is the premium version of ChatGPT, it identifies this because it has pretty strong like visual reasoning. It sees that, oh, it makes 60 degrees from the horizontal, 50 degrees with the vertical. So then it gets well, it still gets... Dude, does it still get the wrong answer? Or do you still fuck up, dude? Wait, 13.1? Yes, this one gets the right answer. Yeah, your answers will be different, Owen, because I think yours has... it depends on what your T-max was, which was a random number. In mine, T-max was 99.7, so this ends up being 13.1 kilograms. But if you have a different T-max, it'll change. So look at that. So 04 mini high gets the right answer, but 4.0 doesn't. Because 4.0 fails to recognize the differences between an angle with the vertical and an angle with the horizontal. It's really cool. Okay. I'm going to go eat some dinner. But I hope this has been really helpful for you guys. A picture for this problem. Oh, nice. Let me see it. Where'd you post it in? In office hours? Oh. One sec. Let me pull this in. I see. Yeah, this is cool. So, this makes a triangle. All right. That's cool, Femvox. Yeah, so this actually makes a triangle. And then you can do law of sines. Wow. Okay, that's cool. That's another way to do it, but that's really cool, Femvox. Law of sines. Yeah. So yeah, you could have identified that all three of these vectors basically creates a triangle, and then yeah, you could figure out the angles, and then you could do law of sines. That's really cool. Again, there's a lot of different ways to solve things. I think the way that we teach you in class, and the easiest way is just do sum of forces, but anyways. Okay, cool. All right. Thank you, everyone, for coming out. Appreciate. Good luck on your final. You guys are going to do absolutely great. Just keep studying. Go through the practice final. Go through the clicker questions. Please show up. If you don't show up, there is no makeup exam. So please show up. Otherwise, I have to give you an incomplete for the course. And I actually don't know what happens after that. So please show up. But yeah, best of luck to everything. Here, we'll go raid someone else on Twitch. But if you want more help with all your stuff, please, follow, subscribe to the YouTube, follow us on Twitch, turn on notifications, and you can I'm always here to help out. So even if you need help with future classes, future physics, future chem, future math, future whatever, we'll be here streaming, and we're here to help. Okay, good luck, students. Yeah, study hard. Nice. All right, let's go raid somebody. Who's on right now? No one really streams. Oh, interesting. Someone's designing some stuff. We'll go say hi to them. Start a raid. It looks like they're doing some AutoCAD. Go say hi to AutoCAD, man.
My man.
Awesome. Okay, cool. All right. Enjoy the rest of your weekend. We will see you guys tomorrow. Peace.